From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 277, recorded live Thursday, July 28th, 2011. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. In this episode, Scott talks with Ivan Towlson from Mindscape about the recently released Web Workbench.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and today we're talking all the way to New Zealand to the folks at Mindscape headquarters. Specifically, we're talking to Ivan Towlson. How are you, sir?
I'm good, Scott. How are you?
Brilliant. Thanks for taking the time. Fortunately, you didn't have to get up in the middle of the night to chat with me today. I appreciate that.
That 4 a.m. was a bit of an alarm call.
Indeed. I blogged last week about some really great stuff that your company, Mindscape, was doing. You put something wonderful out into the community. You gave us the Web Workbench with support for LESS and SASS and what else was in the Web Workbench?
That's CoffeeScript is the third one that's in the Web Workbench.
Indeed. And you gave this away for free. Why would you do that, such a thing?
Well, SASS, LESS, and CoffeeScript, they're all open source products. We thought, we like those products. The creators of those products have given them away for free, and we'd just like to share the love a little bit. We think that it's a useful product for people, but a lot of the ASP.NET MVC community is driven around that kind of those free tools, that shared community. We just wanted to help out with that a little bit.
Well, it's definitely appreciated because one of the things that we talk about when we try to figure out how to get open source driven into the community more when we're sitting around at Microsoft talking about this is how do we get them more interested in these kinds of tools? I mean, I've known about CoffeeScript for a long time, but people, let's just be frank, .NET people don't really like spending time at the command line. At least there's a lot of people that don't, and unless it's in Visual Studio, it doesn't exist. And I think that Web Workbench is a really great way for them to introduce themselves to three extremely powerful tools without having to leave their comfort zone.
I think that's a good point. We've seen that with our other products, that people love the Visual Studio integration. They've got this one central home, and they can just plug lots of things into it. It's a very capable platform, and they can just add in new languages, new productivity tools as they see fit.
Indeed. Now, Web Workbench is cool, but this podcast is not about Web Workbench. Well, maybe we'll do another one some other day. What I think is more interesting and a kind of a larger, more meta issue is that the Web Workbench fits together with kind of three large chunks and uses what we call polyglot programming. There's languages in there that aren't just C#. There's quite a few, I think 4 or 5 at last count.
Just the 4. We were looking at C, but we decided to get away from that one.
Okay, so 4 languages.
We use C#, F#, Ruby, and JavaScript as part of Web Workbench. The reason that we do that is just because there's a number of reasons for doing that. Obviously, SASS is written in Ruby, and we wanted to host the SASS code rather than trying to re-implement it, and that would just be far too much effort. Similarly, the CoffeeScript compiler is written in JavaScript, and again, we just wanted to host that, give people that sort of guaranteed fidelity to the implementation. So we need to be able to host Ruby and JavaScript source code. But we found that those the Ruby and JavaScript implementations weren't performing well enough. They weren't giving us enough output to do things like syntax highlighting and IntelliSense in real time. So we thought, well, we're going to have to write our own parser, our own little highlighting engine for those languages. And we actually found that F#, we've had some experience with F# before, and found that's a really good language for that kind of activity. It's got a lot of constructs that make it very expressive, very concise for writing, in particular language-oriented subsystems.
So Web Workbench pulls together these 3 languages, CoffeeScript, LESS, and SASS, that are domain-specific languages. They are languages themselves. So like SASS, for example, if you looked at it, you'd say, oh, that's CSS. But it's not. It's cascading style sheets with some additional semantics. So it's fair to say that it is its own grammar.
That's right, yes. It builds on CSS, but because it adds things like variables and functions and mix-ins so that you can reuse code. For example, you can specify a color once as a variable, and you can then use that again and again and again. You can apply functions to it, say, for example, to lighten or darken it. So although all CSS is SASS and all CSS is less, they add these additional capabilities that give you a lot of code reuse within your CSS or your extended CSS.
So then when you take that plus CoffeeScript, which is a domain-specific language that turns into JavaScript, and less, you get basically language support for 3 new languages that compile down into lower-end languages. Maybe you saw my talk about JavaScript is the new assembler. Really the point about that is that we're up-leveling things. People aren't writing straight JavaScript and straight CSS anymore.
That's right. Obviously, in the early days of the web, everybody was writing JavaScript, but there's been an increasing recognition that while at the core of JavaScript, there's a really great, capable language, it's not necessarily surfaced in the most convenient way. When you look at the hoops you have to jump through to write modern JavaScript without kind of clashing with the global namespace and all of those bad things that everyone warns you about. Mm-hmm. And it begins to drown out your business logic, your core interaction logic in this sea of additional syntax that you need to write to make it safe. And languages like CoffeeScript, and we're seeing other things like ClojureScript, for example, those higher level languages that compile down to JavaScript give you that safety, they give you that expressiveness, while still, because they actually ship as JavaScript, they still run on every web browser. You don't need to get plugins or anything like that.
Is this similar to like a pound defined in C when someone says, well, C is great, but I just hit this thing that's not very expressive and I can express it cleaner like this. And here's a macro that then expands into perhaps obnoxious looking C, but I don't have to think about that. Or is this more than that?
I think this is a lot more than that. So, old school C macros they're not very smart. You can introduce a few simple constructs that way, but a wholesale change to the language, for example, the way that CoffeeScript's a completely different syntax, completely different language to JavaScript. The things that you can write in CoffeeScript, the constructs that you use are not the same as JavaScript. That you write everything in a much different way using a completely different syntax. With CSS, expanding to SASS and less, that's perhaps a little bit more like a macro, but again, it's smart enough to avoid some of the bear traps that macros used to fall into. But yeah, those are kind of extensions rather than replacements.
Okay, so then if it is the case that CoffeeScript is simply a totally different language, it is not JavaScript, then Visual Studio is not going to understand it by default.
That's right.
Okay.
That's right. And the same thing, I guess, with SASS and less. Although Visual Studio can kind of understand the CSS bits, once it starts seeing variables and mix-ins, the Visual Studio CSS highlighter won't be able to get anywhere. It'll fall over.
So you've included support for an entirely new language, 3 entirely new languages inside of Visual Studio, and you've extended Visual Studio to allow this support.
That's right. That's what Web Workbench does, yes.
But you said that when it came time to just do something as quote-unquote simple as syntax highlighting, these interpreted languages like JavaScript and Ruby weren't fast enough. So you started thinking that we're going to need to do this in IL. That's
right. Although Ruby and JavaScript they're obviously very capable languages, but as people are actually typing, you're getting a very quick turnaround as people are typing. There's fractions of a second between each keystroke, and people kind of want to see their highlighting being updated pretty swiftly as they type. And we ran into a couple of issues. So firstly, there was the performance of trying to call out an interpreted language on potentially quite a large file. Another issue we ran into was things like error recovery. So for example, if you've got an error on one line, okay, you can highlight that line as being a syntax error, but you kind of want to be able to keep going and show other lines highlighted as best you can. Okay. And the built-in compilers, the SASS and the SASS and CoffeeScript compilers, they didn't need to do that. Their job was to compile stuff, and anything they could provide for syntax highlighting was kind of off to the side for them. And that's why we ended up rewriting the parser in IL. Or rather, we wrote it in F#, we didn't write it in IL.
Indeed. But it's interesting to me that there must be surely lexers and parsers out there written in C#, and I'm not someone that I know F# is out there, but I'm not going to just bust out F# on a regular basis. It would be like me trying to speak Spanish, right? It would be passable, and I could maybe order food, but it's not a language I'm fluent in. When we start thinking about polyglot programming, it seems extremely imposing that I would go and write something in a language that I'm not even close to fluent in. Do you just happen to be someone who can speak F# as well as C#? Or was it simply a matter of it is so much better for this particular task that the call of F# was too much to resist?
I guess there's a couple of things. I've been following F# for a little while now. I wouldn't consider myself by any means an expert in it, but I've done a couple of small projects in it, so I know my way around it well enough that it doesn't intimidate me. But that doesn't take an awfully long time. F# is not a hugely complicated language. It's different from C#. It requires a little bit of an adjustment of thinking, but it's not terribly difficult to get your head around. It's not intimidating to learn enough to get stuff done. You're right that C# has got lexers and parsers. There's examples like Irony, which is a Codeplex project, and Antler, which is a project that's come across from the Java world and is very highly respected. The thing that I found really attractive about F# was that it just makes it more convenient to express certain constructs. So for example, when you're building a parser, one of the things you need to express is what they call the abstract syntax tree, the AST, which is kind of the representation of your code as an abstract construct, as a set of nodes, if you like. Does that make sense to you?
Well, let me see if I can understand. So if I have something like var I equals 0, something very, very simple,
yep,
that could be expressed as a tree.
That's right. So you break that down into nodes representing the var, which would be, say, a keyword node. The I would be a identifier node. The equals might be, say, an operator node, and the 0 would be a literal node. And so you'd have maybe a method node, which would have those 4 nodes as its children.
And now, is this a tree, or is this an array? Is this simply an array of stuff, or does it get more complicated than that?
It's absolutely a tree, because let's take the example of, in SASS, you can nest selectors within other selectors. So a selector contains a set of properties and potentially other selectors and mix-ins. So a selector contains various things. Since a selector can contain another selector, you can start recursing down that structure, and therefore it's got to be a tree. It can't just be a flattened array. You've got to represent it as that kind of containment structure.
Okay. So when I have an AST node, a node of an abstract syntax tree, why is it easier to express something like that in F# than it is in C#?
Well, when you want to express an AST, you're basically typically going to have classes for each kind of node. So you imagine this being a fairly simple class hierarchy, where you've got maybe a syntax node as your base class, and you have, in your example, you'd have keyword node, you'd have identifier node, and so on. Those would be derived classes of your syntax node base class. Now, in C#, when you want to write those classes, you've got to kind of write them out longhand. You're going to have to write out your base class, and you have to kind of write out each of your derived classes, each of the members of those derived classes, if they've got individual fields to represent what the keyword is or what the variable is and what the list of children is. This becomes quite laborious. You've got to write this all out longhand, and really those are fairly simple data classes. In F#, you can use a construct called a discriminated union, where basically you can create each class, each of those derived classes, on just one line. And you can then do pattern matching over those derived classes to walk your syntax tree hierarchy, to perform analysis on it, to flatten it down for syntax highlighting and things like that. So in that regard, F# is much terser. You can write much less code to do a lot more.
I see. So this isn't an issue of what you are able necessarily to do in one language versus another, but like an example might be to try to say, in German, you say Schadenfreude, and in English you say taking pleasure at the displeasure, at the pain of others, right? they're both kind of, they say effectively the same thing, but one is clear and terse and there's a perfect word for it and I said it and now we understand. Well, alternatively, in another language, I might need a sentence or a paragraph or a photograph to explain what's going on.
Exactly, and different languages are good at different things. You're right that all of these languages are kind of equally capable at some fundamental level. They call it Turing equivalence in the theory world. But different languages are more expressive for different things. We're kind of cultured in the .NET world to look at Visual Basic and C# as the two big examples of programming languages. And we look at those and we say, well, actually, the constructs map pretty much one-to-one. There's not much to choose between them, depending on whether you like keywords or braces or whatever. And a lot of people kind of take away from that, well, all languages are pretty much the same. But when you start looking outside that family, when you start looking at things like F#, you find that there are languages that can do things in different ways that actually turn out to be more expressive for some things. Now, that's not to say that that moving away from C# and Visual Basic is always a good idea. It certainly isn't. For example, there's a lot of tooling that works really well with C# and Visual Basic. If you can write, say, Windows Forms applications in F#, if you really want to write out your Windows form by hand in code with all those button.add statements, but really you'd rather use a visual designer, and that's where something like C# Visual Basic really comes into its own. F#'s not gaining you anything in terms of building a Windows form, whereas with C# and Visual Basic, the designer gains you an awful lot of productivity. And that's where one of the nice things about the .NET runtime is that interoperation between languages. I can use C# for my Windows Forms or WPF or ASP.NET applications where I've got this excellent Visual Studio tooling. And then when I need something that's more algorithmic, I can drop down to F#, which is more convenient, more expressive for those kind of areas.
This episode of Hansel Minutes is brought to you by Careers 2.0. Careers 2.0 is a new service by our friends at Stack Overflow. You're probably all familiar with Stack Overflow, the online Q&A resource dedicated specifically to programmers and programming-related topics. Well, the team at Stack Overflow created Careers 2.0 to provide you with access to great jobs and introduce you to a bunch of great companies that you might consider working for, even if you're not currently looking for a job. Think of Careers 2.0 as a programmer profile. It gives you a platform to show that you're awesome by featuring your proudest contributions to Stack Overflow, GitHub, SourceForge, Bitbucket, anything programming related. You can even add your favorite programming books from Amazon.com. Profiles on Careers 2.0 are free. They're easy to get started, especially by importing your LinkedIn profile. However, there's one catch. Profiles on Career 2.0 are invite only. They did this to keep out the spam and have a high-quality environment. Fortunately for you, as a Hansel Minutes listener, I've got your back. Head on over to careers.stackoverflow.com/HM to accept your invitation today. Once again, that's careers.stackoverflow.com/HM. I hope you like it. Do you think that because .NET launched almost 10 years ago, or actually probably almost exactly 10 years ago, with these languages that were so similar, with the kind of standard set of languages, not functional languages, just kind of imperative ifs and for loops type stuff, and this ongoing kind of schizophrenia, for lack of a better word, that we have between C# and VB, where each is first among equals and there's a constant thumb war, that .NET itself kind of painted itself into a corner, because there were really only all of these languages that were really just syntactic sugar.
I think you're absolutely right there, Scott. In fact, when Microsoft were launching .NET, when they were preparing .NET, they partnered with the academic community in something called Project 7, where they asked people to port, I think it was 7 languages across, so things like a Perl implementation, an early Python implementation, I think there was even a scheme implementation. So there was a bunch of languages that they asked people to implement for .NET to prove that multi-language concept. Now, unfortunately at the time, as you identified, C# and Visual Basic were the big ones, and Microsoft specified something called the Common Language Specification, which was kind of the subset your language had to, the capabilities your language had to implement in order to play nicely with C# and Visual Basic.
Mm-hmm.
And I think a lot of language implementers in those early days got very hung up on that CLS side of things. They wanted to be able to play nicely with C# and Visual Basic, and they, I guess, distorted their language designs, their language implementations, to make sure that they looked like C# or Visual Basic, so that the CLS would come true for them. And that turned out to be a really bad idea. When I think it's Jim Huganin, the chap who wrote IronPython, started looking at this stuff, he didn't care about the CLS. He just wanted to have a really great implementation of Python on the .NET runtime, like he had on the Java runtime. And so he had the insight to break free of that. We must be like C# or Visual Basic. He decided to be like Python. Similarly, F# decided to be like functional languages, in particular things like ML and Objective-Camel, a bit of Haskell as well in there. These language innovators decided they weren't going to try to just be C# or Visual Basic with a different kind of bracket. They were going to be like the languages they wanted to be, and then they'd find their interop points where they came naturally, not forcing those interop points into the languages.
Interesting. So it wasn't that they necessarily made the decision to not do that, to not be saddled by the past. They were just simply literally not saddled by the past. They were not held back in any way because they had no context. They didn't have Visual Basic 3 and Visual Basic 6 and 20 years of that kind of context to even think about.
That's right. Jim Huganin came out of the Python community. He was interested in creating a great implementation of Python, not creating a Visual Basic clone with Python syntax. Very
cool. So that's F#, and you used F# for parsing within your application.
That's right. If I can just butt in there, Scott,
Please.
One thing I also wanted to mention was we talked briefly about parser libraries, and we briefly mentioned that you've got things like Irony and Antler on C#. I wanted to give a shout out to an open source project called fparsec, which is developed by a chap called Stefan Tolsdorf. It's a very unusual parser library, and it's actually based on something that came out of Microsoft Research about, I think, 8 or 10 years ago, called Parsec. And it's a really neat way of actually implementing a parser specification within the F# language itself. So whereas with something like FSLX or Antler, you write your grammars in a separate language, with fparsec, you write your grammars in F# itself. It uses things like operator overloading and infix notation, which is something that F# supports and C# doesn't, to create a very expressive sort of internal DSL within F# that makes it very convenient to express grammars without having to jump out to separate tools. It also means you can, for example, write functions that return grammars. Now, that may seem a really odd thing to do, but one of the benefits that we saw when we started looking at the SASS and LESS side of things is that SASS and LESS have got pretty similar syntaxes with minor variations. They both have the same kind of capabilities. You can use the same kind of AST for them, but you need to, for example, use different variable prefixes. The mix-in notation is different. They have some different built-in variables. And what that meant, fparsec meant that instead of having to write two separate grammar files for these two separate languages, we could write grammar functions that took, for example, the variable prefix as a parameter and returned us a grammar for the appropriate part of the language. And that meant we could reuse a whole load of that shared grammar while still parameterizing the bits of grammar that were different between the two.
Interesting. Are you almost, and forgive my ignorance, it's been 20 years since I was in college writing anything like this, were you almost like removing the need for a switch statement? It's almost like a callback for a grammar. You're saying, when I need this, go here, that function will handle that for you.
Pretty much, yes. It's a little bit different in that an fparsec parser is kind of an object. So it's kind of more like you've got a function that will return a suitable parser. You'll pass in a parameter like the variable prefix, and it will return a parser that understands that variable prefix plus the common identifier rules.
Ah, I see. I see. So it's kind of a different way of thinking about parsing. It's not just the write a grammar in this terse format. It's write a grammar with this language and use the functions that are available in this language and the things that make F# great. So it's a parser for people who like F#.
Exactly. And it means you can take advantage of all of the logic within the F# language, all the capabilities of the F# language, as well as the capabilities of the parser library. You don't have to choose between the grammar format or the language or hand coding things. You can combine the two as best you see fit.
And that really kind of underscores the reason that you would jump out. It sounds to me like F# was a great reason to switch over. I mean, F# itself was a good thing to look at, but it was the existence of fparsec that kind of sold it.
It was a combination of things, Scott. Like you say, there are parser libraries in C#, but it's the capability of fparsec combined with the very condign nature, the very suitable nature of F# for the kind of entities that you need to work with in a language parser.
Mm. Indeed. Sometimes there's open source libraries that I want so bad I'm willing to go through the hoops though. Like if I could get like hprocot HTML parsing in .NET, that would be like amazing. It's like, it's the parser for Ruby.
I agree, and I think that's again one of the interesting things about the polyglot approach is that it opens up the possibility of using those libraries. So, for example, if you can run hprocot under Iron Ruby, then hey, you've got access to that within .NET.
But let's get to that point then. Isn't it complicated? Isn't it interop? I know that if someone were to say, oh, well, I've got this great COM object, I could go and do interop, people would find that distasteful. Why is picking these different languages and working together with them not distasteful? Is it just because they're all IL?
I'm not worried, to be honest. I'm not worried about distasteful. I'm worried about shipping interesting software that gets stuff done. I don't have a problem with using multiple languages where that's the best scenario. If there's a great HTML parser out there and my product needs HTML parsing, I'd rather use the great HTML parser than try to put something together on my own that would do half the job.
But that's you, though. Let me push back. But that's you, and that's why you're on the show. But I would propose that the listeners would think that integrating Iron Ruby or F# into their application, their .NET application, would be a daunting task.
There are certainly bear traps to it. There's certainly pitfalls to it. Now, it's particularly interesting when you start looking at things like Iron Ruby or JavaScript. F#, of course, was designed for the .NET runtime, so it fits very seamlessly in there. Iron Ruby is designed to be an implementation of the Ruby language, which means it has different semantics for some very basic things. For example, an F# string is just a .NET string. It's a C# string. Mm-hmm. They behave in exactly the same way. A Ruby string behaves in different ways. It's got different methods. For example, Ruby strings are mutable, which .NET strings aren't. So you may find, one of the things that we ran across when building Web Workbench was we wanted to pass the SASS code into the SASS compiler as a string. And superficially, it seemed to work. But actually, in some cases, we hit problems with that because the SASS code was taking paths that used Ruby APIs that only worked on Ruby mutable strings. So we had to use the Iron Ruby hosting API to make sure we wrapped everything up in its corresponding Ruby type before passing it over the boundary into the SASS code. But once we'd done that SASS code, of course, is just running on the .NET runtime, and we can get objects back from it, we can get text back from it, we can do all the things that we want to do.
The interesting thing there, though, is that Iron Ruby isn't like incomplete alignment, is it, though, with the latest version of Ruby?
That's right. So, yes, we had a couple of problems with that as well. So the latest version of Iron Ruby advertises itself as 1.9, but it doesn't implement the entirety of the 1.9 specification. So there are some cases where SASS makes a decision about how it's going to call one of its internal functions based on whether it thinks it's running under 1.8 or 1.9. And it saw that it was running under what it thought was 1.9. It called the 1.9 version of the internal function, and IronRuby hadn't got that. It only had the 1.8 version. So that gave us a few headaches to figure out what was going on there. But again, once you've got a little bit of familiarity with the Ruby language, you can start to crack these problems. In Ruby, you can modify classes after they've been built. You can modify classes that already exist. You can even modify built-in classes. So we just wrote a little fragment of Ruby code that added the method that IronRuby didn't implement. We added that onto the built-in string class using a little bit of Ruby code. And hey presto, our problem went away. We didn't have to write a lot of Ruby. It was maybe 6 or 7 lines. But you're absolutely right. You do need to know the language in order to do that. You need to have a little bit of confidence with the language to know what you can do, how you can fix these problems.
What would you tell folks that are listening, that are interested in this idea, but still find it a little bit scary? Where's the best place for them to start thinking about getting involved in polyglot programming and knowing when to make those transitions?
I think the best place to start is to understand what the different languages do, what libraries are available, what are the compelling use cases for the different languages. So in F#, compelling use cases include particularly parsing. They include, for example, heavy algorithmic computation, scientific computation. For example, F# units of measure are very helpful in scientific computation. There's a lot of financial stuff out there for F#. So if you're working in particular domains, then you may find that there are libraries or language facilities in F# that make you go, that's going to be a handy way. That's going to be a handy language for implementing that particular module. Similarly, with Ruby, you've identified, for example, there's a lot of libraries out there, particularly for working with HTML, XML, JSON, things like that. And you may find that those libraries exceed the capabilities of what are available on .NET. Another case where you might want to look at that kind of thing is, for example, if you want to integrate user code. So by using somebody else's library, integrating third-party code, but it's actually very easy to host the .NET Dynamic Language Runtime, the runtime that sits behind IronRuby and IronPython. Mm-hmm. You can host that within your own applications, and you can actually create simple scripting facilities very easily. So if you want to do something like that, that would be a great example for where you might look at that. But you do need to have that familiarity with the languages. You do need to maybe go out and have a look at Don Syme's book on F#, have a look around I think it's tryfsharp.net is a website where you can actually try out F#. There's a lovely website called fssnip.net, which is just little handy snippets of F#. Similarly for Ruby, there's a massive online community for that. There are some great books out there. There are some great tutorials out there. There's great support forums out there. And there's a lot of resources for learning Ruby, huge amount of resources for learning Ruby.
Fantastic. I'll be sure to put all of those links that you've given us on the show notes so that we've got those all in one place. Are there any other things we want to are there any other links or open source projects that we should share with people as we wrap up? We certainly should. We've talked a lot about F#, we've talked a bit about IronRuby, but the other language that we used in Web Workbench was JavaScript. And I just want to give a bit of a shout out to the JavaScript implementation that we used. I think he's actually another Wellingtonian, guy called Paul Bartram, who maintains a project called Jurassic, which is a Codeplex project. Now, Paul's built this, I think, pretty much from the ground up. I don't think he's relying on the dynamic language runtime. I think he's built his JavaScript implementation right from the basics. And we looked at a couple of JavaScript implementations, but I think we looked at 3 or 4. And Jurassic we found really easy to host. It ran the CoffeeScript compiler, which is not a trivial piece of JavaScript. It ran the CoffeeScript compiler first time out of the box. So if people are thinking about using JavaScript as a scripting language in their applications, or if they've got a JavaScript library they'd like to call into, then Jurassic is definitely worth a look. One little idiosyncrasy, one little difficulty we ran into with the JavaScript side of things is, I guess your listeners may not have heard, but there's an environment called Node.js, which is pretty widely used now in the Unix and Linux world, and it's used by things like CoffeeScript and I
I think it's used by SASS as well, actually, but it's certainly used heavily by CoffeeScript sorry, my mistake. It's used by CoffeeScript, not by SASS, to host their command line. So if you're running the CoffeeScript command line compiler, it will actually go through Node.js. And Node.js supplies a bunch of environmental functions that aren't part of the JavaScript language. So, for example, there's a require function which goes and loads a file off the file system, loads another JavaScript file off the file system, and includes that effectively in your module. Now, obviously, most JavaScript engines don't support that because they're running in the browser. You don't want to give them access to the local file system. So it's something that only Node does. But because we wanted to run the CoffeeScript compiler under Jurassic, we kind of had to add that capability to Jurassic. There's a really easy, simple API for doing that. You've got this add global function method where you can implement a function in F# or C#, which are allowed to talk to the file system, and you can expose that to JavaScript. You can add that to your JavaScript system. So suddenly it can take advantage of your F# or C# code. So you've got a really nice two-way interop going on there. You've got your C# driver code, the Visual Studio integration, which calls into Jurassic to run the CoffeeScript compiler. When the CoffeeScript compiler requires those capabilities that aren't part of native JavaScript, they're supplied by your hosting environment. So you've kind of got to call back into C#. So you've got the two languages, again, working hand in hand, each doing what they're capable of, what they're best at. And it makes for a really nice synergy.
I think that really is the conclusion there, is that use the language that helps you accomplish a problem in a way that's natural for that language, for that environment.
That's right. I think the polyglot approach is a very pragmatic approach. You might use the word distasteful earlier on, and I kind of see where you're coming from. And it's a matter of figuring out what are the appropriate trade-offs. Is it worth bringing in additional language for the capability it will give me? Which language should I choose? When should I use it? How much should I put into that language? And I think it's just a matter of you've got Polyglotism gives you more tools in your toolbox. You don't have to use them. Sometimes it's not appropriate to use them. But when you've got the right tool for the right job, it's a very pragmatic approach to take.
Definitely, definitely. Now, folks can check all this out at mindscapehq.com. They can go up there and they can download the Web Workbench for free, as well as check out the other stuff. And then did you say that you had a special link for Hansel Minutes listeners?
That's right. So we're offering 30% off any Mindscape product to Hansel Minute listeners. If you go to the code bit.ly/Hanselman, then that will take you to our discount page, 30% off, and that's up now.
How did you get that? You got Hanselman as your bit.ly link? Before I did? Scandalous.
You've got to move quicker, Scott. You've got to move quicker.
Fantastic.
You can have the Dash Mindscape one.
Oh, brilliant. Well, thank you so much, Ivan, for chatting with me today. I appreciate it.
Thanks for having me on, Scott.
This has been another episode of Hansel Minutes, and we'll see you again next week.